Absolutely. Here's the most detailed, clear, and simple summary of the straight line multiplication method used in Vedic maths and Sternberg system. Perfect for someone with no math background. I'll break it down slowly. What is this about? Trick to multiply two-digit numbers like 43 times 78 quickly without writing the full traditional multiplication steps. It uses a special pattern that looks like straight lines and crosses crisscross, so it's called the straight line method.
Yeah.
Ash, what is multiplication? Multiplication is just a quick way to add the same number again, and again. Example, if you do 4 plus 4 plus 4 plus 4 equals 20, it is the same as 4 times 5 equals 20. What is the straight line method? It's a special method to multiply two-digit numbers using just 3 simple steps. Let's take this example. 4378. Break it like this. 43 equals 4 tens and 3 ones. 78 equals 7 tens and 8 ones. Step-by-step process in super easy words. We will multiply the numbers in 3 rounds. Step 1. Multiply the digits on the right side. Ones hex ones. 3 times 8, 24. Then you just write the last digit 4. Keep the other digit as a carry 2. So far, carry 2, answer 4. Hack. Step 2. Cross multiply X pattern and add. Multiply like an X. 4 comes 8 plus 3 7 equals 32 plus 21 53. Now add the carry from step 1, 55, 5, carry the other 5. So far, carry 5, answer 5, 4. Step 3, multiply the digits on the left side, tens. 4 comes 7, 28. Now add the carry from step 2, 28 plus 5, or 30, full number, 33. Final answer for 3. Let's recap the steps in a table. Step, actions, result, right, carry. 1, multiply right digits. 3 times 8, 24, 4, 2, 2. Cross multiply 4 to 8 plus 3 times 7 equals 53, 55, 5. Multiply left digits. 4 times 7 equals 28, 33, 33, 33. Manas. Final answer. Why is this method awesome? Easy to do in your head with practice. No long multiplication steps. Saves time in exams like CAT, SSC, banking, etc. Works best for two-digit and can be extended further. One more example for practice. 62 to 41. Get down. 62 equals 6 tens, 2 ones. 41 equals 4 tens, 1 1. 2 is 1 equals 2. Write 2, carry 0, answer. Step 2, 6 1 plus 2 times 4 equals 6 plus 8 equals 14. Add, carry 0. Write 4, carry 1, answer 4, 2. Step 3, 6 times 4 equals 21 equals 25. Write 25. Final answer equals.
Final summary in one sentence.
To multiply two-digit numbers quickly, use the straight line method. Multiply right digits, then cross digits, then left digits. Carry over when needed and write down the digits from right to left. Would you like me to make a printable cheat sheet or flashcard version of this? Or would you like more practice problems with full answers? Absolutely. Here's a great detailed summary of the entire explanation of how to multiply two-digit numbers like 4378 using the straight line method, written in the simplest language so even someone with no math background at all can understand. Hashk, what are we trying to do? We want to multiply 4378. This means add 43 to itself 78 times, which is a big task. So we use a shortcut method to do this quickly and easily called the straight line method from Vedic or Trachtenberg math. Break the numbers into digits. 43 has 4 tens place equals 40, 3 units place equals 3. 78 has 7 tens place equals 70, units place 8. We'll now multiply these digit by digit, step by step. Step 1, multiply the units digits. Take 3 from 43, times 8 from 78 equals 24. Now, minus write the last digit 4 in the answer. Carry over the other digit 2 to the next step. 3, 2, answer rightmost digit 4. Step, apply and add. Now multiply across. 4 comes 8 equals 32. 3, 7 is 21. Add them. 32 plus 21 equals 53. Add the carry from step 1. 53 plus 2 equals 55. Now write 5, the last digit of 55. Carry 5 to the next step so far. So far, carry 5, answer 5, 4. At hash step 3, multiply the tens digits. Now multiply minus 4 times 7 is 28. Add through from step 2, 28 plus 5 equals 33. Now write full 33 to the front, no more carry. Final answer, 33, 5. Final 43 times 78 is 54. Quick recap in table form. Step, what you do, result. Write carry, Cantum times carry 5. 1, units, chems units, 3 times 8, 24, 2. Crisscross, 4 come 8 plus 3 come 7 plus carry 2, 55, 5, 5, 3. Tens, 4 come 7 plus carry 5, 33. Why it works? You're really doing this. 40 plus 3 comes 70, 40 comes 70, plus 40, 70, plus 3, 8 equals 2 to 800, plus 3, 20, 210, 20, 24. The straight line method just breaks this down into 3 simple mini steps. Benefits of this method. Super easy once you learn it. Very fast for two-digit numbers. Useful in exams like CAT, SSC, GRE, etc. Helps avoid big and confusing steps. Try another example. 32, 4 through 1, break it down. Step 1, 2 times 1 is 2. Write 2, carry 0 as step 2. 3 to 1 plus 2 times 4 equals 3 plus 8 equals 11. Write 1, carry 1. Minus step 3, 3, 4 plus 1 equals 12 plus 1 is 13. Write 13. Final answer, 13, 1, 12. Would you like me to show how to use this method for bigger numbers, like 3-digit times 2-digit, give you practice problems with answers? Make a printable worksheet or cheat sheet? Let me know. I'm here to make it super easy. Absolutely. Let's now go even deeper into this explanation of how to multiply big numbers like 4, 3, 5, 5, 7, 8 times 6, 9, 9, 21, but still using very, very simple language. I will explain every word, every idea, every as if you are learning for the very first time.
Imagine.
You want to multiply 4, 3, 3, 5, 8, 6, 9, 21. These are big numbers. So instead of trying to do it all at once, we break it into small parts. Step by step, like building a tower. We'll go digit by digit, starting from the right and moving to the left. Step by step explanation of each part. Step 1, find the unit's digit, the very last digit of the answer. Look at the last digit of both numbers. Last digit of 43358 is 8. Last digit of 6921 is 1. Multiply them. 8 times 1 equals 8. This means the last digit of our answer is 8. Write it down. 8. 8. No carryover because 8 is only 1 digit. Step 2. Find the tens digit, the second last digit of the answer. We now need to figure out the next digit to the left, the tens place. To do this, we multiply digits in a crisscross way. Which digits? Look at second last digit of the top number equals 7. Last digit of the bottom number equals 1. So 7 comes 1 equals 7. Then last digit of top number equals H. Second last digit of the bottom number 2. So 8 times 2 equals 16. Add both results. 7 plus 16 equals 23. Now we need to write only one digit, the units digit of 23, and carry the other. Write down 3, carry over 2 to the next step. So now the answer is 38. 3 is the tens digit, 8 is the units digit. Step 3, find the hundreds digit, third digit from the right. Now it gets a bit bigger. We will now use 3 multiplication pairs. How do we choose which digits to multiply? Use this trick. Start from the middle and move outward. Start with 5, third last of top, times 1, last of bottom. 5 times 1 equals 5. Then move right on top, 7 left on bottom 2. 7, 2 equals 14. Then move right again on top, 8 left again on bottom 9. 8 times 9 equals 7 them all. Now add the minus 5 plus 14 plus 72 equals 91, 2. Don't forget the carryover from the last step. That was 2. 91 plus 2 equals 93. Now write 3 as the hundreds digit, carry over 9 to the next step. So the answer is now 338. 3 is hundreds digit, 3 is tens, 8 is units. Summary of these 3 steps so far. Place, what we did, total, term, digit to right, carry, night 2, units, right, 8 times 1, 8, 8, tens, 7 times 1, verve, plus 8 times 2, 23, 3, 2, hundreds, 5 times 1, 7, 2, plus 8 nines, carry 2, 5 plus 4 times plus 7, 2, 93, 9. In easiest words possible, you start at the end of both. Absolutely. Here is a detailed summary in the simplest, clearest, and easiest English, explaining everything again, word by word, step by step. Detailed summary. Topic: how decimal and percentage values from a ratio. 1. What is a ratio? A ratio compares two numbers. Example, 2/5 means we are comparing two parts with 5 parts. It can also be like a fraction, 2/5. 2. What is a decimal? A decimal is a number with a dot that shows a part of a whole. Example, 0.5, 0.25, 0.75 are decimal numbers. They are another way to write a fraction or a ratio. 3. What is a percentage? A percentage is a number out of 100. It tells us how many parts out of 100. Example, 50% means 50 out of 100. 4. How are they all connected? The ratio, decimal, and percentage all mean the same thing, just written in different ways. For example, ratio 1/2, decimal 0.5, percentage 50%. They all show the same part of something. 5. Steps to find decimal and percentage from a ratio. Let's say we have a ratio AB. Step 1. Write the ratio as a fraction. Write it like this. A or B, AB. Example. If the ratio is 2/5, write it as 2/5 or 2/5. Step 2. Divide. Now divide the numbers. 2/5 equals 0.4. This is your decimal value. Step 3. Multiply by 100. Now take the decimal and multiply it by 100. 0.400 equals 40%. This is your percentage value. Final answer, ratio 2 to 5, decimal 0.4, percentage 40%. Easy rule to remember. Ratio divide decimal, multiply by 100, percentage, hash. More examples, ratio, decimal percentage, 2%, 3, 4, 0.75, 75%, 2, 5, 0.40%, 1 to 10, 5 to 0.625, 62.5%. What's useful, helps in exams and schoolwork, used in shopping, used in data, science, and everyday life. Final thoughts. Ratios, decimals, and percentages are just different ways to show parts of a whole. Once you learn one, you can find the others easily. You always do. Divide, get decimal, multiply decimal by 100, get percentage. Would you like a printable cheat sheet or some easy practice questions next? Of course, let's go even deeper into ratio comparisons in the simplest, most beginner-friendly way. Step by step, word by word, like you're learning this for the very first time. What are ratios? A ratio is just a way to compare two numbers. It tells us how many times one number contains the other. Example, if you have 2 red balls and 3 blue balls, the ratio of red to blue is 2:3. We can also write this as a fraction, 2/3. This means for every 2 red, there are 3 blue. What is ratio comparison? Sometimes you're given 2 different ratios and you are asked, did the ratio go up or down? Is it bigger or smaller than before? Why do we compare ratios? You might need to compare ratios when prices change, speeds change, quantities change, scores change, anything else that grows or shrinks. Let's learn the 4 simple cases. When something changes, 2 parts of the ratio can change. The numerator, top number, the denominator, bottom number. Now let's study all 4 possible cases. Case 1. Top number goes up, bottom number goes down. Example, old ratio equals 3/6, new ratio equals 6/3, top number increased, 3/6, bottom number decreased, 6/3. Now let's turn both into decimals. -3 for 6 equals 0.5, -6 for 3 equals 2.0. 2.0 is much bigger than 0.5. So ratio increased, no need to calculate. This case will always increase. Case 2, both top and bottom go up. Example, old ratio 2/3, new ratio equals 4/6. Now check, top 2, 4, bottom 3, 6. Now divide both. -3 equals 0.666. 4, 6 equals 0.666. Here the ratio stays the same, but in other examples it might go up or down. You must calculate in this case. Case 3, top goes down, bottom goes up. Example, old ratio equals 8/4, new ratio 4/8. Check, top 8/4, bottom 4/8. Now divide, 8/4 was 2.0, and a 4/8 0.5. 0.5 is much smaller than 2.0, so the ratio decreased. You don't need to calculate. This case will always go down. Case 4, both top and bottom go. Example, old ratio equals 8/10, new ratio equals 4/5. Check top 8, 4, bottom 10, 5. Now divide minus 8 over 10 equals 0.8, 4 over 5 equals 0.8. Here they are equal, but in other examples it might go up or down. You must calculate in this case. Final cheat sheet summary. Case: what changes ratio increases or decreases? Do you need to calculate? 1 top bottom ratio increases? No. 2 top bottom could go up or down? Yes. 3 top C bottom ratio decreases? No. 4 top bottom could go up or down? Yes. When you must calculate, use one of these two methods. Method 1, just divide top by bottom for both ratios. Example, compare 5, 6 and 4 fifths. 5 over 6 equals 0.833, 4 over 5 equals 0.8. So 5, 6 is bigger. Method 2, cross multiplication shortcut. Compare 2/3 and 3/5. Multiply minus 2 times 5 equals 10. 3 times 3 equals 9. Compare the results. 10, 9, so 2/3 is bigger than 3/5. This is faster than dividing. One last super simple example for practice. Compare. Old ratio equals 10/20. New ratio equals 12/18. Step 1, check what changed. Top 10 from 12 increased. 20/18 decreased. This is case 1. Top bottom ratio will increase. No need to calculate. Final tip, when comparing ratios, if you're unsure, calculate the decimals or use cross multiplication. If the change is obvious, like case 1 or case 3, you can answer quickly. Would you like me to give you a worksheet to practice this? Explain ratio problems with pulls, money, marks, speed? Help with a tricky problem? I'm happy to go further with you anytime. Of course. Let's now go even slower, even simpler, with full step-by-step explanation, as if you are hearing it for the first time. Sure, nothing is confusing. We'll go line by line. What are we trying to learn? We want to compare two fractions, ratios, like as 173,211 to 181,225. We want to know which fraction is bigger without using a calculator. But instead of dividing the numbers, we will use a shortcut method. It's called numerator denominator percentage change method. Step-by-step explanation, super simple. Step 1, what is a fraction or ratio? Think of a fraction like a piece of cake. The top number, numerator, tells how many pieces you have. The bottom numerator tells how many pieces the whole cake is cut into. Example, minus 1/2 means I have 1 piece out of 2 pieces, means I have 3 out of 4 pieces. So fraction equals. Step 2, what are numerator and denominator? Every fraction looks like this. A equals numerator top number, B equals denominator bottom number. Example, in 173,212, 173 is numerator, 2 and 12 is denominator. In 181,225, 181 is numerator, 225 is denominator. Step 3, why are we using this method? Imagine you're in an exam and you don't have time to divide. 173, 212 equals 181 over 225 equals. You need a smart way to compare the two fractions quickly. That's why we use this trick. Compare how much the numerator and denominator changed. Step 4. What is changing? Look at the two fractions again. First fraction, 173/212. Second fraction, 181 and 225. So what happened? Top number, 173, 181, 112, bottom 12, 212, 225. Both went up. Now we ask, how much did they go up? We do this using percentage increase. What is percentage increase? Let's say you had 100 and now you have 120. You got 20 more. Now, how much is 20 more in percent? Use this simple formula. Percentage increase equals increase over the original 100. Here, 20 over 100 is 100. It equals 20 cent. So 120 is a 20% increase from price of 100. Now let's go back to our fractions. 5. Find percentage increase for numerator. Numerator to 173, 181. Change equals 181 minus 173. Now apply the formula. 8 for the 173. Adds the 100 to 4.6 cents. So the numerator increased by about 4.6 cents. Step 6. Find percentage increase for denominator. Denominator 212 and 225. Change is 225 minus 212, 13 two-law time rules. Now apply the formula. 13 for the 212, 100, 6.1 cent. So the denominator increased by about 6.1. Step 7. What does this tell us? Now we compare both increases. Top numerator grew by 4.6%. Bottom denominator grew by 6.1%. So the bottom grew more. Important rule. If the denominator grows more than the numerator, the new fraction becomes smaller. So 225 is smaller than 173, 212. Even though both numbers are larger, the bottom number grew more than the top, so the total value goes down. Simple cake example to help you understand. Imagine this. First, you had 3 pieces out of 6. 3 6 equals 0.5, half the cake. Then you got 4 pieces out of 10, 4/10 equal 0.4, less than half the cake. Even though you got more cake pieces, 4, the total cake became much bigger, 6/10. So your portion got smaller. Same idea here. Shack summary, super simple. 1, you are given 2 fractions to compare. 2, you check how much the numerator and denominator changed, cent. 3, use this formula. 2 change over original, 100 by 4. Numerator increases more, fraction becomes bigger, denominator increases more, fraction becomes smaller. 5, this trick helps compare close ratios quickly and easily without dividing. Final tip. This method is most useful when the numbers are close. You are good at calculating percentage. You don't want to waste time dividing. Would you like to try some examples with me now? Sure, let's go even slower and even simpler. I'll explain it like I'm teaching a total beginner. No math background needed. First, what is a ratio? A ratio is like a comparison between two numbers. Example, you have 2 red balls and 4 blue balls. Then the ratio is 2:4. This means 2 red for every 4 blue. Another example, if you have 5 mangoes and 10 apples, ratio equals 5:10.
How? Now?
What is percentage change? When something increases or decreases, we often say by how much in percent. Example, if a price goes from 100 to 110, that's a 10% increase because 110, 100, 100 by 100 equals 10%. What is percentage change in a ratio? Let's say you had a ratio of 20/40 and now the ratio changes to 22/50. We want to ask, how much has the value of the ratio changed in percent? It seems a bit tricky, but don't worry, we'll use a very easy method. Step-by-step way to do it, super easy method. We will break it into 2 parts. 1, look at the top number called numerator. 2, look at the bottom number called denominator. Part 1, numerator change. Old numerator 20, new numerator 22. So it increased. How much? How much? Let's calculate. New old comes 100 equals 22 minus 20 e by 20 comes 100 equals 2 by 20 100 equals 10% increase. So the top number increased by 10%. Part 2, denominator change with reverse logic. Old denominator 40, new denominator 50. So it increased too. But wait, there's a trick. When the bottom number increases, the ratio value goes down. So we need to take the reverse effect. We imagine what percent change would bring 50 down to 40. Joe? Formula, old, new 100 equals 50 with some 40 where 50 come 100 equals 10 to 50 comes 100 equals 20% decrease. So we say the effect of the denominator equals 20% decrease, reverse way. Combine both effects. Now we start with 100, like 100% value. 1. First apply the numerator change. Now is 100 plus 10% equals 110, 2. Then apply the denominator change. Minus 110, 20% equals 110 times 0.8. Now it's 88 at the end. So original was 100, now it is 88. That means 12% decrease. Final answer. The ratio value decreased by 12%. Why we do this? You may ask, why break into numerator and denominator? Because changing the top or bottom changes the ratio differently. If the top number increases, ratio increases. If the bottom number increases, ratio decreases. So we look at both effects one by one. This method makes it easier and faster. Another super simple example. Let's try. Old ratio is 10 for 20 on. New ratio equals 15 30. Step 1. Numerator change 10 15 equals 15 10 minus 10 of 10 comes 100 equals 50% increase. Step 2. Denominator change 30 20 in reverse. 13 is 20, 30 comes 100 equals 33.33% decrease. Start with 100, increase by 50% equals 150, decrease by 33.33% equals 150 comes 0.6667. So no change. Final ratio is the same. Why? Because 10 by 20 equals 0.5 and 15 by 30 equal 0.5. Same ratio, so 0% change. The golden method summary. Whenever a ratio changes from AB to CD, step 1, find percent change in numerator equals CAA because 100. Step 2, find percent change in denominator reverse called DB 100. Step 3, start with 100, add numerator change, then subtract denominator effect. Final value tells you percent change in the ratio. Try this now. Old ratio was 30/60. New ratio was 36 for 75. Step 1, numerator change 30, 36, 20% increase. Step 2, denominator reverse effect 75/60 equals 75 to 60. 75 equals 20% decrease. Start at 100, 100 plus 20% or 120, 120.896. So ratio became 96. This means 4% decrease. If you want, I can give you practice problems and check your answers. Would you like that? Sure, let's go even slower and even simpler. I'll explain it like I'm teaching a total beginner. No math background needed. First, what is a ratio? A ratio is like a comparison between two numbers. Example, you have 2 red balls and 4 blue balls. Then the ratio is 2:4. This means 2 red for every 4 blue. Another example, if you have 5 mangoes and 10 apples, ratio equals 5:10. Now, what is percentage change? When something increases or decreases, we often say by how much in percent. Example, if a price goes from 100 to 110, that's a 10% increase because 110, 100, 100 times 100 equals 10%. What is percentage change in a ratio? Let's say you had a ratio of 20/40 and now the ratio changes to 22/50. We want to ask, how much has the value of the ratio changed in percent? It seems a bit tricky, but don't worry, we'll use a very easy method. Step-by-step way to do it, super easy method. We will break it into 2 parts. 1, look at the top number called numerator. 2, look at the bottom number called denominator. Part 1, numerator change. Old numerator 20, new numerator 22. So it increased. How much? How much? Let's calculate. New old at old comes 100 equals 22 minus 20, go to e by 20 comes 100 equals 2 by 20, 100 equals 10% increase. So the top number increased by 10%. Part 2, denominator change with reverse logic. Old denominator 40, new denominator 50. So it increased too. But wait, there's a trick. When the bottom number increases, the ratio value goes down. So we need to take the reverse effect. We imagine what percent change would bring 50 down to 40, Joe? Formula, old, new, and new 100 equals 50 with some 40 where 50 come 100 equals 10 to 50 comes 100 equals 20% decrease. So we say the effect of the denominator equals 20% decrease, reverse way. Combine both effects. Now we start with 100, like 100% value. 1. First, apply the numerator change. Now is 100 plus 10% equals 110, 2. Then apply the denominator change. Minus 110, 20% equals 110 times 0.8. Now it's 88 at the end. So original was 100, now it is 88. That means 12% decrease. Final answer. The ratio value decreased by 12%. Why we do this? You may ask, why break into numerator and denominator? Because changing the top or bottom changes the ratio differently. If the top number increases, ratio increases. If the bottom number increases, ratio decreases. So we look at both effects one by one. This method makes it easier and faster. Another super simple example. Let's try. Old ratio 10 for 21. New ratio equals 15:30. Step 1. Numerator change 10:15 equals 15:10 minus 10 of 10 comes 100 equals 50% increase. Step 2. Denominator change 30:20 in reverse. 13:20, 30 comes 100 equals 33.33% decrease. Start with 100, increase by 50% equals 150, decrease by 33.33% equals 150 times 0.6667. So no change. Final ratio is the same. Why? Because 10 by 20 equals 0.5 and 15 by 30 equal 0.5. Same ratio, so 0% change. The golden method summary. Whenever a ratio changes from A B to C D, step 1, find percent change in numerator equals CAA because 100. Step 2, find percent change in denominator reverse called DB 100. Step 3, start with 100, add numerator change, then subtract denominator effect. Final value tells you percent change in the ratio. Try this now. Old ratio was 30/60. New ratio was 36/75. Step 1, numerator change 30, 36, 20% increase. Step 2, denominator reverse effect 75/60 equals 75/60. 75 equals 20% decrease. Start at 100, 100 plus 20% or 120, 120.896. So ratio became 96. This means 4% decrease. If you want, I can give you practice problems and check your answers. Would you like that?